In this video, we are going to talk about one-dimensional motion and some of the basic parts that we'll need to study it. Okay, so one-dimensional motion is just motion along a straight line, and that's it. And so one really nice tool that we have for visualizing these motion problems is going to be Desmos.com. And so let's just take a look at sort of the setup that I have for these one-dimensional motion problems right here. So you can see here the object that's moving is just represented by a dot, right? And it's just moving back and forth along a straight line, right? On a number line here, and that's it. Okay, so it doesn't curve or go off or deviate from the number line. The number line doesn't curve or anything like that. It is a straight line, and the particle or object or whatever you want to call it, right, is just moving back and forth on the number line in this example right here. In the next video, I will show you how to set up these motion problems on Desmos.com, so you can take a look at them yourself. All right. So a couple of the key things that we'll have in these motion problems is first the coordinate system. So for us, the coordinate system, it's going to help you describe the motion of the object. And so in pretty much any of these motion problems, we will have that. And for us, right, we are just talking about one-dimensional motion. Our coordinate system will always be a number line. So that's it. So just for right now, the coordinate system, just a fancy name for a number line. We're talking about moving back and forth on a straight line, and so we're just going to have that the number line as our coordinate system. Okay, if you have motions in 2 dimensions or 3 dimensions, then you're going to have more than just a number line, but we'll save that for calculus 2 and 3. Okay. All right, so some very important aspects of the number line is the 0 point right here and the positive direction. Those always need to be specified for a number line. Here, so far, we've just pictured the number line as being straight up and down or horizontal like this, but we could easily have a number line kind of in the vertical direction if we're talking about free fall problems or things like that. And so the coordinate system will always be a number line, but you can choose the 0 point kind of wherever you want to, and then choose the positive direction. So those are really the two most important choices that you need to make about a coordinate system. In most of the problems that we'll deal with, it's not critical that you make those choices. They'll kind of be made for you, essentially by something that we'll talk about here in just a minute. But in an arbitrary problem where they don't give you, say, the motion, or in other problems later that you'll encounter, maybe if you take calculus 2, it's kind of up to you to choose the coordinate system. And those are really the choices that you need to make. Okay, I know that for one-dimensional motion, it's going to be a number line. Where do you want to put the 0 point on the number line? Maybe if it's a problem about a free fall problem where you are dropping an object off from some height, right? Maybe you want to put the 0 point at the ground level. Or maybe, right, if you're dropping something off a building or something like that, maybe you want to put the 0 point at the top of the building. Okay, and then the positive direction, usually if you're talking about, say, like a free fall problem, the positive direction is usually up, although, there's nothing that says that you can't take it pointing in the towards the ground in a free fall problem like that. And you might say, well, won't that affect the problem where I choose the 0 point and which way I choose to be positive? And the answer is, well, the calculations will be affected and things like that, but your answer should wind up to be the same as somebody who took the the 0 point at a different place, or the positive direction in a different direction relative to the coordinate system. So really and truly, it doesn't matter. Theoretically, in some practical applications, it might be easier. Some choices might lead to easier calculations than others. So For right now, we won't have to worry about it. I just want to mention this so that you'll know behind each one of these motion problems, we have this coordinate system here specified. And for us in this class, it's just going to take a really simple form, just the number line. The other critical thing that we have is the position function. And the position function will give the position of an object on the number line at any time t. So really, if you want to be technical about it, what it gives you is the displacement of an object. And if you take physics class, you'll probably hear your teacher, physics teacher, say talk about displacement. And I will talk about that in subsequent videos. But for right now, let's just think of it as the position function here. So the position function, it gives you the position or location of an object that's moving around on the number line at any time t. And so, for example, we might have a position function that looks like this. F of t equals the sine of pi over 2t. So this is just a function that we have. We usually take this variable instead of being x to be t, right? Because the t represents the variable time, and that's what we're looking at here. Instead of the x coordinate, right? We really want to think of this as the time variable. So the particle starts moving, right? And the clock starts running. And so we usually take the time to be starting at 0 here, like in this example right here. Okay? And this is actually the equation on the example that I showed you earlier in the class, early in this video here. So say we wanted to know where the object is located after 3 seconds, right? What we would do is plug in 3 for the time variable right here and calculate that out. We get sine of 3 pi over 2, and the sine of 3 pi over 2 is -1. So what would happen is that 3 seconds right after the object starts moving, right, it would be located at position -1 on the number line here. So let's pop this open and stop this. Okay. And here I have A representing time. There's a reason for that, and I'll go into that when I do the next video about how to plug these things into Desmos. So for right now, I just want to slide this over to 3. And oops, let's make it exactly 3 here. And here at 3 seconds, we can see that the particle or object is located here at -1 on the number line. Say we wanted to know where the particle is located at 5 seconds, right? We could plug 5 into the position function and we'll get a 1 right here. Okay, so then if we just fast forward this a little bit so that we get 5 up here, we can see that the particle is located at 1, right, on the number line right here. Okay, so that's what the position function does, right? The position function tells you where the particle is located, right, at the on the number line at any given time right here. And so what Desmos does here, right, is it just basically allows you to let time run here, and it automatically calculates where the point is going to be located, and so you can actually see the motion involved here. Okay, so we have one-dimensional motion. That's motion on a straight line, right? So that straight line there is our coordinate system. It tells us, gives sort of a reference as to where we can locate the point. And then we have the position function, and the position function describes the position on the number line, right, of the particle right here. And so it moves back and forth, right, according to that form there.